Namaste, welcome to Group 1 Services Mains Examination Orientation telecasted by TSET. So, aspirants, now you are eagerly waiting for your preparation and performing in the examination. Everyone knows it about the paper 5. The paper 5 has two components, one is science and technology and second one is data interpretation and problem solving. So, there are three sections, everyone knows it. The section 1 and section 2 comes under science and technology, and section 3 comes under the data interpretation and problem solving. So, now we are going to discuss about the problem solving and data interpretation. In this area, we are going to discuss about number sequence, of course, number series also, sometimes we call it as a progression also. So, everyone knows it, we can play with numbers and there are so many kinds of numbers, even numbers, odd numbers, perfect squares, perfect cubes, sad numbers, happy numbers, dependent numbers, like there are n number of kinds of numbers and there is an n number of number series also. Arithmetic progression, geometric progression, harmonic progression, arithmetic geometric progression, okay, Fibonacci series, triangular numbers, like there are so many series also. So, the examiner can give any kind of number series questions in this particular pattern. So, we are trying to give the complete and comprehensive information to you to score maximum marks in this examination. In order to that, so we are going to discuss about all the concepts, especially the consent to the number sequence. The last sessions we discussed about arithmetic progression and geometric progression. Now we are going to discuss other kind of progressions like harmonic progression, arithmetic geometric progression. Just now I said triangular series, triangular sequences, all these things. So now we will discuss about harmonic sequence and series. We call it as harmonic progression also. A harmonic sequence is a sequence where the sequence is formed by taking the reciprocal of each term of an arithmetic sequence. For example, 1, 1 by 4, 1 by 7, 1 by 10 is a harmonic sequence. Just I will give a clear information to you. So, when you take it as 1, 4, 7, 10 and so on, this is an AP, arithmetic progression. When 3 is added to 1, we will get 4. When 3 is added to 4, we will get 7. When 3 is added to 7, we will get 10. Means by adding a fixed number, so a next number will be generated. That is an arithmetic progression. When you consider the reciprocals of these numbers, means 1, 1 by 4, 1 by 7, 1 by 10 and so on. The reciprocal of the numbers which are in arithmetic progression will form harmonic progression. That is a simple idea. A series formed by using harmonic sequence is known as harmonic series. For example, so already I said the difference between a sequence and series. Sequence means only the numbers will flow, where in series the addition of these numbers means 1 plus 1 by 4 plus 1 by 7. So, now all aspirants can understand what is the nth term of harmonic sequence. So, whereas in arithmetic progression an equal to a plus n minus 1 of d. So, the nth term of harmonic progression is Tn equal to 1 by a plus n minus 1 of d, like a very simple one. So, like what are the properties in arithmetic progression? We are going to use the same kind of properties in harmonic sequence also. Now, we will shift to the next one, that is triangular series. So, triangular series means this is a number series in which the first n represents the terms linked to dots presented in figure. For a triangular number, the dot shows the amount of dot required to fill the triangle. Are you understand? For if you want to draw a triangle by using dots, what is the minimum number of dots required to construct a triangle? See it, 1, this is 1, this is 1. So, means here how many of it? 3, correct. So, 3 dots. The first, so this is a 0 area triangle, correct. Now, this is 1, this is 3. Now, we will take this is 1 point, these are 2 points, 3 points. Is it form a triangle or not? Observe it. A triangle formed. Am I correct? So, here how many one? This is 3, these are 2 and this is 1, totally 6. So, 1, 3, 6. For example, if you take it as bigger one, this is 2, we will take 3, now we will take 4. Now, join all this, a triangle formed or not? Triangle formed. So, how many dots are used here? 4, here 3, here 2, here 1. 4 plus 3 7, 7 plus 2 9, 9 plus 1 10, correct. So, 1, 3, 6, 10, 15, 21. Okay. So, generally you have a doubt, sir, we want to put the dots and join whether the triangle formed or not. Like, can you generate a triangle series? No need. So, here when you observe 1, 3, 6, 10, there is a formula you can generate. That formula is n of n plus 1 by 2, that is it, simply n of n plus 1 by 2, or you can say n square plus n by 2, because n of n is n square, n of 1 is n, n square plus n. Now, if you have in doubt, substitute the values 1. If you substitute 1 first, means 1 square plus 1 by 2, which is 1 plus 1 2 by 2, 1, correct. Substitute 2 there, 2 square plus 2 by 2, means 2 square plus 2 is 6, 6 by 2 is 3, correct. Take 3, 3 square plus 3 by 2, 3 square is 9, 9 plus 3 is 12, 12 by 2 is 6, correct, 1, 3, 6. So, the general formula for a triangular number is n square plus n by 2 or simply n of n plus 1 by 2, like you can generate the numbers. What is the importance of this triangular numbers means? Generally, we are using these triangular numbers in Pascal triangle and other areas also. Where you are using the Pascal triangle? Generally, we are using the Pascal triangle concept in the binomial coefficients, like we have an extension of this concept. So, this is about a triangular series. Are you understand? A triangular number can be generated by using the formula n square plus n by 2, that is the information. Okay. Now, see, I show this one by a dots, already I showed it. So, when you use one dot, it is a 0 area triangle, correct. Okay. Now, I use 3 dots here. By using the 3 dots, a triangle formed. Next, here how many dots are used? 6 dots are used. So, is another triangle. Now, take a bigger triangle of this one. How many dots are used here? We have one more, because when you join this, like this is a line which is parallel to the one side. So, this is another triangle. How many dots are used? 10. Here one more triangle formed, correct. So, how many dots are used here? 15. So, 1, 3, 6, 10, 15, all these numbers are called triangular numbers. For example, I asked what is the 6th number in the triangular series? 6th number, how we are going to calculate? 6 square plus 6 by 2, correct. 6 square plus 6 by 2, 6 square is 36, 36 plus 6 42, 42 by 2 is 21, 21 dots. Understand? So, next number after this means here it comes as 21, like you can calculate in the required number in the triangular series, that is it. Okay. Now, squared series. Square means basically by its name you can understand a perfect square. So, here the very important, do not get any kind of confused. So, there is a perfect square and a perfect number. A perfect number is in the form of 2 power k minus 1 of 2 power k minus 1, where k is greater than or equal to. This is called the general formula for a perfect number. Then what is a perfect number? A perfect number means if the sum of the factors of a number is twice of the number, that number is said to be a perfect number. For example, if you take 6, what are the factors of 6? 1, 2, 3 and 6. These are the factors. What is its sum? 1 plus 2, 3, 3 plus 3, 6, 6 plus 6 is 12. Sum of them 1 plus 2 plus 3 plus 6 is 12, which is twice of the number. This is called a perfect number. But what is a perfect square? If a number is multiplied by itself, that is called perfect square. 1 square is 1, it is a perfect square. 2 square is 4, it is a perfect square. 3 square is 9, it is a perfect square. 4 square is 16, it is a perfect square. 5 square is 25, is a perfect square. So 4, 9, 16, 25, 36, all these numbers are said to be squares and square series. So here it is a pattern. So previous one is there is a rule. Now here a pattern. What is a pattern? Those are the squares of the consecutive numbers. 1, 2, 3, 4, 5, 6 are consecutive numbers. 4, 9, 16, 25, 36, their squares. So a square number is simplifying the product of an integer with itself. Square number always positive. Generally, what is the necessity for using the square numbers? Because the area of any closed plane figure units are square units. So square units means that is very important. The square numbers are used to find the area of a closed plane figures. Understand? That is the reason we are using this plane figure. And a very important note is the square of any number, any real number is positive. That is a very important thing. Clear? Okay. So like we have some more applications of that one, we will discuss those things also, but initially the square number is okay. And very important note is 1 square plus 2 square plus 3 square plus so on up to n square. The sum of squares of n natural numbers, its value is n of n plus 1 of 2n plus 1 by 6. This is the value. This is a very important formula, n of n plus 1 of 2n plus 1 by 6. For example, if you want to know 1 square plus 2 square plus 3 square plus 4 square plus 5 square, we will calculate. What is 1 square? 1. 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. So 1 plus 4 plus 9 plus 16 plus 25. 1 plus 4 is 5, 9 plus 16 is 25, 25 plus 25, 50, 50 plus 5, 55. So the sum of first 5 square numbers is 55. By using the formula now, how we are going to calculate it? Just say n is 5, correct? N plus 1 6, 2n plus 1 2 into 5, correct? 2 5 is 10, 10 plus 1 11, 2n plus 1 11, correct? This is 11 by 6. This 6 and 6 get cancelled, 11 5 is a 55, am I correct? See, that is an advantage of the formula. If you want to find the sum of n perfect squares, that value is n of n plus 1 of 2n plus 1 by 6. Here my sincere request and appeal to all the aspirants who are going to write this examination is, in this particular sessions we are going to discuss the number series. There are so many formulas we are using, better to note those formulas and practice it, that will give a complete. Who are non-mathematics background aspirants, these formulas are very important, because who have the maths background, those people doesn't feel any difficulty to follow these kind of concepts, but who are not mathematics background aspirants, those people have to note all this information. So when you are seeing this one, come with paper and pen, pen and pencil. So note all the formulas, definitely that will help you to give the good score in the examination. Okay, now we will see one more. Next, a cubic series. So previously we discussed a square. What is a square? The product of two numbers which are same. The product of the same numbers is called square. Now cube means here, when you multiply the number 3 times, that number is said to be a perfect cube. Means a is multiplied by 3 times, means a of a is a cube. 2 of 2 is 2 cube, which is 8. 3 of 3 of 3 is 27, which is 3 cube. 5 of 5 of 5 is 5 cube was 125. Clear? Like, so all these 1, 8, 27, 64, 125, 216, 343, 512, all these are perfect cubes, and this will form a cube series. A cube number series is a series which is generated by the multiplication of a number 3 times by itself. The general formula for a cube number series is xn is equal to n cube. Clear? So, like you can find the cube of number. And a very important, when you are going to discuss it, we have to discuss the very important thing is the Ramanujan number. So, the Ramanujan number, why I said the Ramanujan number means here, there is a number which can be expressed as sum of 2 cubes in 2 different ways. Among these numbers, this is the smallest number, that number is 1729. 1729 can be written as 10 cube plus 9 cube one way and 12 cube plus 1 cube another way. This is the one of the number which can be expressed as sum of 2 cubes in 2 different ways. This number is highly familiarized, popularized as Ramanujan number. Srinivas Ramanujan, everyone knows Srinivas Ramanujan, the greatest Indian mathematician. Recently, we celebrate National Mathematics Day on the name of the birthday of Ramanujan sir. Correct? So, that is 1720 is concerned to the Ramanujan. So, this number is called Ramanujan number concerned to the cubes. So, this is the smallest number which can be expressed as sum of 2 cubes in 2 different ways. Like, so, like we can give so many application questions in this particularly a cube series. Okay. Now, we will see the next series, Fibonacci series. So, Fibonacci series has a wide application in our general daily life situations. We have vast applications. When you count the petals in a sunflower, so those are in Fibonacci series. When you count the seeds in that, also in the Fibonacci series. The rabbits will generate their generation in the Fibonacci series. Like wide application of the Fibonacci series in our life, in daily life situations. Then what is a Fibonacci series? That is a very important. A mathematical series consists of pattern in which the next term is obtained by adding the 2 terms in front. Means here each number is generated by sum of the 2 preceding numbers to it. 2 preceding numbers. Means here the series will start, for example, if you consider as 1 1, 1 plus 1 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 8 plus 5 or 5 plus 8 is 13, means 1 1 2 3 5 8 13. This series is called the Fibonacci series. Understand? So, each number will be generated by sum of 2 preceding numbers. Okay, 2 is generated by sum of these 2, correct? And 3 is generated by sum of these 2, and 5 is generated by sum of these 2. Like, so each number is generated by sum of its 2 preceding numbers. That series called Fibonacci series. A very useful series it is. A lot of application is there. So, we will discuss what kind of questions we will ask in this Fibonacci series, but very familiar, and it is concerned to our daily life observations also. Clear? Okay. Now, we will see one more, that is called twin series. So, twin series means generally in the prelims examination also some questions are asked on a twin series. Most of the people, without knowing about twin series, they are trying with different kinds of permutations and combinations. Finally, they said the question may be wrong. No, actually we have to observe what kind of series it is, because nearly 2 or 3 questions may ask in the number series in the even prelims also. So, observe it here 3, 4, 8, 10, 13, 16, correct? 3, 4, 8, 10, 13, 16. So, when you take it as a single series, it is 3 plus 1 is 4, 4 plus 4 is 8, 8 plus 2 is 10, 10 plus 3 is 13, 13 plus 3 is 6. There is no uniformity pattern, correct? So, it is not an arithmetic progression, it is not a geometric progression, it is not a harmonic progression, it is not a square series, or it is not a cube series, or it is not a Fibonacci series. Then you have to think it is a neither of all these things. Then we have to think that is a very important. But when you observe the numbers alternately, so when you observe the numbers alternately means here, when you come to this 3, 8, 13 number. So, one series 3, 8, 13 and so on, one series. Now, coming to the next one is 4, 10, 16, 4, 10, 16. So, 3, 8, 13 is one series, 4, 10, 16 is another series. When you consider 3, 8, 13, 3 plus 5 is 8, correct? 8 plus 5 is 13. So, what is the next number comes? 13 plus 5 is 18. So, after this number 18 will comes, correct? So, it is an arithmetic progression. Here the common difference is 5. Now, come to the next 4, 10, 16 and so on, means 4 plus 6 is 10, 10 plus 6 is 16. So, 16 plus 6 is 22. After 18, 22 will come, correct? Like you have to prepare, identify the twin series. In the series, so sometimes it is a combination of two series, two sequences. So, you have to identify and divide that one as two series, identify the next number, what next number will come. In this manner, the twin series questions may come in the examination. So, please identify it, do not rule out simply this is a wrong question in the given examination. So, identification of the problem is a very, very important. After twin series, we are going to discuss about one more kind of series, that is called arithmetic geometric progression. Arithmetic geometric progression. Already we discussed arithmetic progression, already we discussed geometric progression. Now, we are going to discuss about combination of arithmetic and geometric progression. What is an arithmetic progression? If the number is generated by either addition or subtraction, either increased or decreased by a fixed number, that sequence is called arithmetic sequence. Am I correct? Okay. Now, geometric sequence means each number is generated by multiplying the previous number by a fixed number, then it is called a geometric sequence. Means here now arithmetic geometric sequence, here two kinds. One is arithmetic geometric sequence, another one is geometric arithmetic sequence. That is very, very important. So, when comes here, so arithmetic means here when you multiply, okay, we will see it 1, 2, 6, 36, 44, 440. 1 plus 2 means here, observe it, I will show that here how it is. So, addition and multiplication, we will see those things, how it is explains come. Now, verify an example 1, 4, 8, 11, 22, 25, correct? 1, 4, 8, 11, 22, 25. So, here 1 plus 3 is 4, 4 plus 4 is 8, 8 plus 3 is 11, 11 plus 11 is 22. It is not an arithmetic progression. So, it is not a geometric progression also, like even it is not a twin series also. Then we have to check it this 1 plus 3 is 4, 4 2s 8, 8 plus 3 is 11, 11 2s 22, 22 plus 3 is 25, 25 2s 50, next number is 50. So, here what will come? 50 will come. Now, observe it 1, 4, 8 plus multiplication, plus multiplication, plus multiplication, plus, okay, arithmetic progression. multiplication geometric progression. Clear? So, arithmetic geometric progression. This is called arithmetic geometry, means arithmetic progression property and geometric progression property both will come simultaneously. Such kind of progression is said to be arithmetic geometric progression. Are you understand? So, it is arithmetic and geometric mixing. So, once again I am giving a very clarity to this about arithmetic geometric progression means first the arithmetic property will come, next geometric property will come. Clear? Okay. Now, come to the 1, 2, 6, 36, 44, 440. So, here when you see this 1, 2, 6, 36, 44, 440. 1 into 2 is 2, means multiply with 2, add 4, correct? Add 4, multiply with the 6, okay, add 8, multiply with the 36 plus add 4, multiply with the 10, okay, like. So, what we have to add with 12? Now, observe it. The first one you multiply with 2, add 4, then multiply with 6, add 8, then multiply with 10, add 12. So, the next number will come 452. Here, very important thing is, it is a geometric arithmetic series. Geometric arithmetic, this is a geometric arithmetic series. The previous one is arithmetic geometric series, this one is geometric arithmetic series. Here the difference of the numbers, what is the difference between 1 and 2? 1, 2 and 6 is 4, this is 30, this one is 8. Now, observe it. Okay, so here 1, 2, 6 means 1 is multiplied by 2, you get 2. 2 is added with 4, you will get 6. 6, okay, and 2 plus 4 is 6 now. So, 6 is multiplied with 6, you will get 36. Now, 6 plus 4 is how much? 10, correct? So, and what is the next number after 6? 8. Now, observe it, 2, 4, 6. So, next number 8. So, you have to add 8, 36 plus 8 is 44. So, next after 8 we will get 10. So, here first multiplication, next addition, next multiplication, next addition. So, next multiplication into 10, 44, 440. So, next this is a multiplication, next addition will comes 2, 4, 6, 8, 10. So, next number comes 12. So, we have 440 plus 12, 452. So, answer is 452. So, this is called geometric arithmetic progression. Understand? So, means multiplication, addition will comes alternately, but the difference of that numbers is in arithmetic progression. Now, observe it, 2, 4, 6, 8, 10, 12. All these are in arithmetic progression. So, that is a difference between arithmetic geometric progression and geometric arithmetic progression. You have to identify these two. This is a very important thing. Are you understand this one? So, in arithmetic geometric progression, just first addition, then multiplication. Addition and multiplication comes continuously. Whereas in geometric arithmetic progression, so first multiplication, then addition. Multiplication, addition comes alternately. But this one, of course, the numbers in this series, they are increasing arithmetic progression. So, maybe you understand this concept, arithmetic progression and geometric progression, the differences and how it. This is a very crucial, a very important progressions. You learn arithmetic progression, you learn geometric progression. This is arithmetic geometric progression. This so we have some more progressions, some more series. We will discuss those in the next session. Okay. Until thank you.